Hey, I'm Caleb from YouCanMakeThisToo. In this video, we're going to talk about dust collection and some really common mistakes. I want to start that off by talking about why dust collection is important and how we do it, which is going to inform some more conversation later. But we're also going to get into a lot of just real nuts and bolts, common mistakes, and how to design the most effective and efficient system that you can within your budget. First up, why do we do dust collection? Well, you have to. It's not really an option. Either you have an automated system that's helping you handle it at the time of production while you're making the chips, shavings, dust, or whatever combination it is you make, or you let it build up till it's such a problem that you gotta break out the leaf blower or dustpan and broom or whatever it is you do to clean it up, and cleaning it all up then while it's also like coated every surface in the space that you work in. So you're either doing it as you go or you're doing it afterwards. The other big reason, and the reason you want to stay on top of it and have some type of automated system to take care of it while you're producing it, is for health and safety. Take care of your lungs, because if you're not doing anything else, then your lungs are your air cleaner, and that's not a good way to go. That's very hazardous because wood dust can cause cancer, and not just in the state of California. Anywhere in the world. Nasal cavity cancer is one of the leading kinds that it causes. And besides that, COPD is another real risk. Forget what it stands for, but basically it means your lungs are screwed for life and they're never going to get better. And the really scary thing about COPD is by the time you're symptomatic and you're starting to show symptoms of having COPD, you've already done irreversible damage to your lungs and they're never going to go back to how they were before, which is a really good reason to stay advantage of that, because by the time you know there's a problem, it's too late. Now you've got to live with that for life. It can be really easy as a hobbyist to dismiss that second part, the health and safety and risk, and think, well, I mean, I'm not doing this all day, every day. It's not my job. I just do it for fun on occasion. So I'm not going to get exposed enough to be at risk. But there's been some interesting things I've heard lately saying that the average hobbyist in a few hours working in their garage is exposed to more fine wood dust particles, the dangerous stuff, than a production woodworker is in months in most shops. And the reason for that is hobbyists spend a lot of time working with tools like these that produce lots of dust and don't collect well, if at all, the exception of my Mirka, except only if it's hooked up to its dust extractor, which we'll get into that kind of stuff later. Whereas in a production shop, they're mostly dealing with machines that are set up for proper dust collection and extraction, with huge dust collectors that pull massive amounts of air that's sized properly for all that equipment, and lots of ventilation and everything that's needed. So their air stays relatively clean, whereas, you know, OSHA is not coming to inspect your shop to make sure your hobby's not killing you. But when you're a production shop, you might have to be inspected for insurance reasons to make sure everything is good and you're not going to harm your employees and get sued. The other reason hobbyists are at high risk is just lack of knowledge. Even if you have a system, it might not be set up well, or it might be giving you a false sense of security and you think it's doing a whole lot more than it really is. In your wood shop, you produce dust, shavings, and chips. These are like wood shavings and chips. They're off my helical, so you get the idea. They're really big, easy to see. Obviously, I can't breathe those, and those are actually the easiest thing for most dust collectors to pick up. Now, the first dust collector I had a bag that everything dropped into that, and above that was a cloth bag that was the filter, and it filtered down to 5 microns. Now, here's the interesting thing is what's dangerous to us is between 0.3 microns and 10 microns. Particles in those sizes are what's most dangerous to our health. And really the 0.3 to 5 micron is kind of the most dangerous. Over 5 micron are everything in your nose that filters the air. Does a pretty good job at catching that, but between 5 and 10, you know, some stuff is going to get missed that can still be harmful to your lungs. Now, if you pay attention to the bags that filter down to 5 microns, all they're actually doing is catching the stuff not very dangerous to you and blowing out all of the stuff most dangerous to you at head level. So if you have a bag type dust collector and you think, hey, I'm doing dust collection, it's picking up all that heavy stuff and I really don't see dust because that stuff is too small to see. Still, human hair is a lot bigger than 10 microns. You're actually increasing your risk potentially over not having that dust collector because you're ejecting all of it at head height with the velocity, through a fan, a pump basically that's blowing it right at you. So the best style filter on your dust collection, if you can afford it, is to have some type of cartridge. This is a Win cartridge, and they filter up to 99.9999% of all particles down to 0.3 microns. So for your dust collector to actually be doing what it needs to, you really need to have a pleated cartridge filter, and you want something that filters effectively down to 0.3 microns to have the most health benefit. Another thing that's going to help your filter efficiency is how much actually has to get to the filter. I have a 2-stage, so this has a cyclone. Everything comes into the cyclone and spins down, and most of my waste goes into this bucket, and then whatever doesn't goes up at the top and then into the filter and gets pushed back out as clean air. But I'm sort of pre-filtering with this cyclone, which helps keep my filters clean longer so I don't have to clean them out as much, which also helps my efficiency. I know there's some theories of like, well, hey, don't clean your filters, just let them, get all clogged up, because then as the opening in your filter pleats gets smaller, less stuff will be able to get through, and it's going to filter even finer dust. The problem with that is there's a really simple equation on how much air your dust collector can draw in, and it can only draw as much air as it can push out. Otherwise, it's turning into a compressor and compressing air. And none of these are pressure vessels, so it really can't compress and hold air. It's just going to, the less air you're able to push out through this filter, it's either going to find its way out somewhere else, which then is not filtered, or it's not going to be drawing the air in. And if it's not drawing the air in, your motor is going to get overheated and you're wearing down the life of that. And also, you're just not pulling all the air you need at the tools to collect those chips and shavings, because the filter can only filter what it actually gets, and the separator can only separate what gets to it. If you're not collecting it at the tool, then it's just going into the air. So maximizing how much air flow you have at the tool to collect those things is critical. Now that we've gone over why dust collection is important and a little bit of the fundamental concepts behind it, we can talk about the first category of issues that mistakes fall under, which is getting enough air at the tool to actually do your extraction. Of course, the first part of that would be starting with your system and having a system that draws enough air. Fortunately, there's handy tables out for this. I'll put one up on the screen, and you'll see for like standard hobbyist equipment, which I have some larger equipment, you're looking at needing between 400 to 600 CFM pulled at the tool. That's not what the collector can pull at its port, what you're actually pulling at your tool. And CFM is a measurement of volume of air. It's cubic feet per minute. Now, there's some important caveats. One, that's only actually to collect chips and large dust particles, not the fine dust that's actually really harmful to you. And also, that chart assumes that dust ports and hoods have been replaced. It doesn't say, but I'm going to assume with something that's actually effective and not necessarily what came with the factory equipment. Because as you know, if you look at a lot of these machines, dust collection is often an afterthought. For example, my table saw actually has this really cool chute around the blade that is then tied and connected to my dust port on the bottom. So all the dust actually does get like physically shot towards that dust port, and the air being pulled through it is guided to and around the blade. It's not just a hole in the cabinet that's just generally pulling air out of the cabinet and isn't being concentrated. Also, I upgraded and had this nice overarm dust collection hood. The thing about this though is if I keep this thing up, it's really not going to do me much good. What I have to do is have it set almost at whatever my material thickness is. I normally push it against my material, then raise it up just a tiny bit and set it there, because then there's a much smaller air gap around this thing between it and the material that's going to pull from, and it's going to focus on actually getting the material that my blade is trying to blow in the air. This is the first saw. I've had several table saws. This is my first saw that's had anything like this, and I've tried to use other ones and they just didn't really work well at all. So that's another thought, is your tool even actually collecting? Because if all you have is a port drilled into the side of the hole of a table saw body, but nothing collecting over the blade, you're not even collecting a whole lot of fine dust. It's literally just throwing it right at your face. So however great your filter is and however much air is being pulled at the cabinet is really irrelevant if you have a spinning blade launching fine dust right at your face as far as protecting your lungs goes. So that ties into air cleaners and PPE, which we'll talk about more later. But yes, how do we get the most amount of air at the tool? One, try to select tools that have good ports, or modify them if you need to, or build them. Here's a great example of a really bad job. This 1890s planer that I had is just an open top and literally just blew everything right at the top. So I got some sheet metal, there were some tapped holes, and I screwed it around and I hooked up dual ports. So, but you know, there's still lots of ways that fine dust can escape this. It is not perfect, but it actually works pretty well. But that's the handy thing about having my dust collector, because really if you want to get up to fine dust territory, you need to be pulling at least 1,000 CFM at your tools to begin collecting that fine dust. And at most of my ports, mine's pulling like 1,500. It's pretty obscene. So I can actually pull some of that collection, and I'm pulling enough air that I can overcome some air gaps. So that's something to consider. Of course, I hear you. Well, Caleb, that's great if you can spend $3,000 on a dust collector, but I can't do that. I can't overpower issues with just suction. What else can I do? Another thing you can do is try to use rigid pipe over this flexible ribbed stuff, because all the texture along this pipe and all the bends and curves increases resistance and drops your airflow. The more smooth pipe you can run through, the more you're going to preserve the air that your fan or impeller can pull from your extraction system to your tool. So try to minimize runs of this stuff. If all you have is one hose coming off of your system that's all flex, you're going to be losing a whole lot of air. So if you're doing any type of permanent install, spend the money, buy rigid pipe, get your rigid pipe installed, and minimize your run. You'll notice in my shop, I have the one main line on this side coming over, and everything is hard piped. And then only at my CNC over there, I have a box where it splits into the flex pipe to go to the machines. Same thing here, I got as close as I could. Same thing on my jointer. But on my bandsaw here, instead of running this flex pipe, which wouldn't be very supported and get all kinked, and having all this flexible stuff bending unsupported, would lose a whole lot more air than rigid stuff. So I got some 4-inch PVC and built my turn to be able to shorten my flex pipe runs as much as possible to minimize the air loss due to this stuff. So got it. Minimize how much flex pipe you use because it kills your airflow. It's a good tip. Another common mistake is not running the largest rigid pipe that you can. I have a 6-inch inlet on my Clearview, so I've piped 6-inch pipe everywhere. I don't neck it down until I get to a tool. All my tools have 4-inch ports or smaller, but nowhere do I neck down from 4-inch pipe to, or 6 to 4-inch pipe just to neck it down to preserve airflow. When you start reading, you'll often see a lot of like articles and charts and graphs that talk about when to neck down and how much to neck down, but that is really set up for very large shops that are going to have multiple tools all running extraction at the same time, and collectors that pull thousands upon thousands of CFM, and you're talking about like working at 12-inch ducking and necking it down over runs that might be hundreds of feet. You know, we're talking about collectors that work at 2,000 CFM or lower and runs that are normally 50 feet or less, and you're only going to be running maybe one tool at a time, 2 tops. You're just gonna hurt your brain trying to figure out when and how much to neck down. And especially if you're talking about a 6-inch port, like just run 6-inch everywhere. It's gonna preserve the air. Now you may think that 6-inch to 4-inch isn't gonna be enough of a difference to worry about, and you wanna save the money and run 4-inch pipe instead. But 4-inch pipe over 6-inch pipe, 6-inch pipe actually has almost twice the area of a 4-inch pipe once you do the math, and that's because the area of a circle has a square relationship to its radius. So a 4-inch diameter pipe has a 2-inch radius, 2 squared is 4. A 6-inch pipe has a 3-inch radius, 3 squared is 9. So we just went from 4 to 9 that then we're going to apply pi to. So a 6-inch pipe can pull twice as much air as a 4-inch pipe. Thinking about that, that also gets into another mistake, I feel like, which is not addressing your fittings properly. Now, where I have to split down to my tools, I use These splitters made by Clearview, but anyone can order them, and they're sized to fit with 6-inch flex hose or 6-inch drain pipe. I use 6-inch drain pipe. And then it has 2 4-inch ports, because if 6-inch pipe pulls twice as much as a 4-inch pipe, then 2 4-inch pipes pull the same amount of air as a 6-inch pipe. So every time I have to neck down my 6-inch, I make sure that I have 2 4-inch ports, so that way I'm not starving my system of air, can draw all the air that it needs to, and maximizing the flow at both. Also, a lot of my tools have 2 ports. They're dual port setups. So I want each of those to get the most airflow possible. Something I see a lot is because 4-inch fittings are cheaper than 6-inch fittings, and you can get away with less fittings. I see people being like, well, hey, instead of running 6-inch pipe and then having to buy a 6-inch Y and then having to buy 2 6 to 4-inch reducers, I can buy, which is 3 fittings, I can buy 1 6 to 4-inch reducer and then buy 1 4-inch Y. And that 4-inch Y is going to be a lot cheaper than a 6-inch Y, and I'm only buying 2 fittings, and those fittings are cheaper. The problem is you're necking that 6-inch down to a 4-inch, so you just constrained your airflow by half, and now you're taking that half and you're trying to split it, but you still just created a huge bottleneck that has a whole lot of resistance that's going to absolutely kill your airflow. And if you've already invested enough in a system to be able to pull enough air that you're talking about running 6-inch pipe, it doesn't make sense to try to save a little bit of money on your fittings and kind of invalidate all the money you just spent on your dust collection. Another important point or a common mistake, like we talked about, getting everything as much as possible to the tool or to the system once you've collected it at your tool, is sealing all your joints. You can, glue your joints or caulk them or tape them. I like tape because you can always cut it and remove it and pull things apart easier. Another tip, I actually normally screw these too. So when I'm putting together, I'll use sheet metal screws, pre-drill a hole, run 2 screws into every fitting, and then that way everything kind of stays together, and then run tape around everything to really seal it up. Another thing to consider with your pipe and airflow is smoothing your runs. That is, 90-degree bends are really hard. I only have one 90-degree bend in my whole shop. Otherwise, you'll notice I have Ys, and where I need to make 90-degree turns, what I do is I hit a Y and then I hit a 45, because my Ys come out at a 45. The 2 45s equal my 90s. And then up here in the corner, where I had to make a 90-degree bend off the ceiling, you notice it's actually 2 45s put together. But otherwise, everywhere you see, it's always a Y and then a 45 or multiple 45s. A great shot of how to do that is right up there. You can also see that I used the Y and then plugged the end, but I left it as a Y in case I need to run off more from there later. And I have a short section of pipe, then another 45 that's smooths the airflow and isn't near as rough, so you don't lose as much air, because any sharp bends increase resistance. One place I have a Y is right, or 90 is right there, because as you see, let's just go into a clean out where I have some other hose that I can use for general cleaning. So that actually isn't for any dust collection at the tool. I just use that for cleaning. So, if it sucks things up, it does. If it doesn't get it all, it doesn't get it all. I'm just using that to pick up piles. Something else to bear in mind, this isn't necessarily a mistake per se, it's an approach. There's kind of 2 thoughts on blast gates. You either have them at the tool or you put them where your branches split, so that way you minimize how much dead air is in the system. Dead air being runs of pipe that are connected to the system through open gates, but that don't have an inlet. My philosophy, is in a small shop where you're dealing with relatively short runs. I think I have less than like 100 feet of pipe in here, is I put all my gates at the tool because I want it to be easy, because easy things get done and get used. If I had to have like handles or run around my shop all the time to open and close gates to have tools, then it's going to be a lot easier in that moment to be like, I'm just going to make one cut, one pass, just got 2 boards to do whatever, and not use the dust collection system, which is the worst thing I can do. So I like to make it easy and just keep everything at the tool. And with the runs I have, it's not going to make much of a difference. Even with all the open pipe or dead pipe, all my ports still pull at least 1500 CFM. So it doesn't really matter. I have 2 main branches that kind of come off, and I debated about whether or not I needed to add a blast gate to separate those. So depending on which branch I was working off of, I could kill one whole section of my dust collection system and focus the air, but I got it all set up without those and then tested all the ports. And once I realized how much air I was still pulling at all my ports, I was like, well, that would just be a waste of money and extra headache for me that I'd probably end up just not using. So I skipped that. But yes, think about your gate placement. Now, that being said, in my old shop, I actually did my blast gates at the elbows because I had a weaker dust collection system, or I put them at the splits, but I also had 8-foot ceilings and most of my blast gates were at 7 feet. So I could reach up and hit the blast gates. So instead of putting blast gates at the tools, I put them where I could kill branches, and that worked well. So just think about your situation and what's gonna work best and what you're gonna use the most. And speaking about making it easy with your blast gates, that's probably one of the most common and also easiest to fix problems. And that is not using whatever system you do have. Please use it. One of the best ways you can make sure you use it is to make it as easy as possible to use. The easier things are, the more likely they are to be used. So that includes things like making your blast gates accessible so it's not a hassle to get to it. Having a remote control. I got a remote control for my dust collector so that stays clipped on my belt whenever I'm going to be running any machines, so I can just hit it on and off. I don't have to walk across the shop. If you have a shop vac type setup or smaller dust collectors that maybe are dedicated to your tools, maybe look at getting the automatic switches that you plug both tools into, so whenever you turn the tool on, it trips and turns on your vacuum. I have a Merca dust extractor that I run my track saw and routers and sander on, and it works like that. I can plug my tool into the vacuum, so whenever I turn those tools on when I'm running them, it kicks on the vacuum and it works. It's another way to keep it easy. If you can hard pipe everything and use gates instead of having to disconnect and reconnect your tools all the time, do that so you don't have to connect and reconnect. If you have a small mobile system that you have to move around and disconnect and reconnect tools, Rockler makes some really nice quick change ports that you can put on your hose and also on your tools to make it really easy. You just grab the handle, put it on your tool, take it off, slap it to another so you're not dealing with hose clamps. If that's out of your budget, these are not much more expensive than regular hose clamps. I'll have a link where you can get these on Amazon, but get yourself some hose clamps with a little thumb screw so you don't have to go chasing tools to take your hoses on and off. Just whatever you can do to make it easy so you're going to use it, do that. Because ultimately the best system is whatever you'll actually use. Doesn't matter how great a system is if you don't use it, even if it's just for a few cuts. And now circling back to sort of the elephant in the room, which is why bother with all that if the air's still going to be full with the most dangerous stuff to me, and what do I do about that? Well, as I got into, the whole idea is the more you can keep out of the air, the less you're going to breathe. So even if we aren't collecting all of what's most harmful to you at the tool with that system, mine is pulling a whole lot of air. I'm blessed enough to be able to afford that and to have done the work to put that in and have that. So I am still reducing a lot of fine dust particles from even getting close to my face. Some other things I've done is I have multiple air cleaners in my shop that then scrub the ambient air, and I also make sure to wear a dust mask, as much as I remember, that is rated really well and fits me properly. This is a stealth mask. I like it because it goes on and off really fast and easy. Again, if it's easy, it gets used. So I use that whenever I'm running tools that make a lot of dust. Fortunately, most of my processes I feel are very good at capturing dust, except for my miter saw and hand tools, because on my jointer, everything is fully enclosed and the chips are being created in a closed environment where everything can get suctioned really well. Same thing on my planer, that's a very closed environment. Same thing on my table saw, I have under and over collection. So it's only whenever I have to do something where things aren't fully enclosed, or I've got to move the arm off my table saw, that I'm in an environment where I'm not going to be able to capture almost everything, or like I'm using the miter saw. That one's just notorious. So in those situations, though, I make sure to wear my PPE and also run my air cleaners, which is always your fallback. If you're just watching this for entertainment and long-term planning, and you can't set up a good dust collection system and put air cleaners in and all that, this is going to keep everything out of your lungs. If you have a good rated mask, like a stealth mask, that catches all the particulates down to the 0.3 microns that you need, then you don't have to spend thousands of dollars invested in everything else. You can buy a $35 mask that's going to keep your lungs perfectly safe regardless of how much is floating in the air. It's just the more we can do there, the less work this has to do, and the less you have to worry about wearing this. One big note on if this is your primary source of protecting your lungs is make sure that you don't take this thing off as soon as you're done using the tool. Because if you aren't collecting all that stuff, and even if you are, you got to realize that you're still blowing a lot of it in the air, and just because you're no longer creating it doesn't mean it isn't still floating around for you to breathe. So if you don't have, a fully optimized system, and even I always make sure to never take this off for several minutes, make sure that my air cleaners have had a time to at least cycle all the air in the shop a couple times before I take my mask off, or go out of the shop before I take my mask off, because you're kind of minimizing your gains if you do everything and then as soon as you finish, you take off your mask and start breathing all that sweet, fine carcinic dust in the air as soon as you're done making your cuts. So anyway, not to scare anyone, I just wanted to share some of the knowledge I've picked up. I hope you learned something, were inspired, or maybe a little entertained. Anyway, until next time, make time to make something, and I'll have links to as much as possible down below if you're interested in any of the specific products I talked about. Thanks.